Hello, everybody. Thank you for joining us here at Zillow, or Zillow Tower, as I like to call it. If you wouldn't mind taking a seat, maybe taking your conversations a little bit down so I can start presenting. Thank you for coming again. My name is Bernardo Macias. I am the Splunk technical architect, apparently, and this is the Splunk boss. Well, thank you for joining and calling me Splunk boss, but this is Zillow Splunk like a boss, custom commands. Have to look at the actual slide to actually know what it is, but thank you again for joining, and I'll begin my presentation. I'll be off to the side since I need my reference notes. Before I begin, I'd like to say if you have any questions, just raise your hands. I want this presentation to be interactive, but if they're too long, I'll ask that you hold those to the end of the presentation, but I'll try to answer those as quickly as possible if you hold up your hand. So this is a little bit about me. You can read about this. I've had quite a bit of experience with Splunk. Been doing IT for quite a while. I got other interests that you can see. Just the newest one is probably stateful configuration management. I'm trying to learn Salt Stack and have some familiarity with Chef. Moving on. So I'm going to cover 4 items, and the last one being the demo is probably the things you guys probably came to see. But a brief overview, getting started with actually developing your command and adding your own Python packages to Splunk. Okay, so what is a search command? In Splunk, they're basically little programs that allow you to stream and do reporting on data, generate data, transform the data by doing calculations of aggregates, and tell Splunk how to retrieve data from its indexes. That's the basics. There's a bunch of commands, but this is about building your own command. So building your own command, there are 3 basically general types of custom Splunk commands. A generating command, which just simply generates data like your input CSV, input lookups, metadata. The reporting command is one that basically does stats, is like stats, time chart, top. Stream commands are those like eval, where, that basically let you take data and add data to it, streaming and adding new fields to your raw data. But let's get getting started. So to get started with building your own custom search command, you kind of need a few things: Python, the pip, virtual environments and the wrapper, an IDE of your choice, a text editor, the Splunk Python SDK, and your own local instance of Splunk. I highly recommend doing your own local instance of Splunk because if you have done any development, it's easy to break production. And if you're using an IDE, I'd actually recommend using PyCharm because it lets you do a lot of other cool things, such as use Django, which actually is a framework inside of Splunk. So you can do not just custom Splunk commands, but you can do Django if you wanted to inside of Splunk. Because Splunk is really just a development framework that you can just do just about anything that you normally would do. So if you look at this, this is basically the anatomy or directory structure of a custom command. And you can see here that it's pretty simple. The top directory is the name of your command. The meta directory is basically the default permissionings that you want to give out to your command, and whether it be global, only certain users can run this command, and that's how simple it is to actually permission it. The bin directory is actually probably the most important directory, which is actually where you store your custom Python command and any additional binaries, executables, eggs, any other libs or packages that you want to install. And the default directory, which is also similar to the local directory, contains a bunch of config files, which the app.conf that defines the name of your application, what it is, what it does. The commands.conf. The commands.conf actually is the definition containing what your command is and the location of your command. The logging definition. And the myfirstcommand.conf is basically the same name as your command that actually contains like the variables such as username, password, other information about your command and how you want it to run. And the search NF is basically descriptions that you kind of like those, see those, we click into the search bar and you see all these like, hey, this is how you use the command. It's basically the definitions that display that. There are a lot of individual files, but most of the time you don't have to really care about those. The only ones you really care about is the commands.conf and the configuration file for your command. The Splunk XDK comes with a bunch of different examples. I recommend starting with the generate command. Generate command is actually the easiest command to actually get working and kind of see and playing around. And so let's talk about what I have on the screen here. If you've done Python development, you can see all things you normally see, such as the import statement, which just imports the library, and the from statement, which imports the select methods from a Python module. And you see this little funny symbol, the @ symbol with a configuration. I don't know how many of you guys have actually seen that or are familiar with that, but that's just called a decorator. So what a decorator is basically Splunk has done some extra work for you and basically created a function that wraps around this class object and basically changes and modifies the output. It's the simplest way to describe it. But you don't have to worry about that much. There's some arguments you can pass in there, but for this, you actually don't have to worry about it too much. And the class name. The class name is basically this custom class that you're making that's basically inheriting from the string commands class. And so the strings command class and the generate command, reporting command is where Splunk has already done all the hard work for you, so you don't actually have to do any real coding. Did you have a question? Oh. So, and you see below there, you can see field name, pattern. These are just the options and variables that you want to pass to the custom Splunk command. And it's basically another function that just populates a lot of the required validation for you. So you don't actually have to validate and do any of the real hard work, fortunately. And then you see just below that the stream, the def stream, which is basically where all the magic happens. So if you're familiar with classes in Python, you can see self, which is basically allows this instance to reference itself and pass anything that's been variables and whatnot are within this instance. And then records are basically all the records that are currently being piped to your Splunk command. So if you're familiar with how Splunk works, you do a search, a pipe, and then you basically do another command. So this is basically taking all the records that are from the previous command and basically shoving it through one by one in a list. So you see here there's a for record in record. So basically each record is actually a dictionary object. And so it's very simple to work with. So you iterate through it. You get to the, you go here and then now you do for field name in fields. So basically you're looking for a record inside the dictionary item. I believe I said that right. And you can see some other stuff going down here. You can set if it's matching the length. And then on the last step here, you see record self.file name equals count. So basically, you're just shoving the count into the record, and you're just redisplaying that dictionary object. And so the bottom right here is the actual part that's actually running it, the dispatch. And don't have to worry about that. You can follow this little template, and you can actually get going with your first command. And you can rip out anything here and kind of start messing around, playing around. But I think the biggest problem I ran into, or I see people running into occasionally, is how to present my data inside of Splunk. Since it is a dictionary object, and you want to like make it feel like an actual, like Splunk is actually searching inside the actual data stores, I actually created a function called toJSON, which basically takes any dictionary object, turns it into a JSON payload, or basically a text or a string, and outputs it in simple JSON. And then you can use that, and basically, like here you see below where I'm using pull info dict, is basically I'm creating a dictionary object, and then inserting in each individual key value that I want to be actually in the extracted fields portion of the output, and then assigning to JSON pull info into the raw field. So if you're familiar with Splunk, the _raw is basically the raw data and how it appears inside the Splunk. And below, I give a couple of ideas. Like here's how you how like the dictionary item will look. And then at the very bottom, you see yield dictionary mymeta.items plus mydict.items is basically an easy way to combine your dictionary items into one dictionary. Does anybody have any questions? I know I'm probably stuttering, going over a little quick. No, it's not. So that's the actual basically your so in the command you have a bunch of arguments, and so that's your argument that you're creating that the user can pass in something. So if you look up right below the line that says count matches command, fields is actually the argument that you're letting the user assign something to. Did that answer your question? So building commands, this may seem like a lot, but it's actually fairly simple once you get going. Now that I think,
That would imply, though, that there's something that you wanted to do that's not already available in one of the stats reval functions, right?
Yeah, that's correct. If you feel like there's a stats command that it's not available, or you feel something that you need to build something to either touch another API, touch something and actually present it like it's a real, like Splunk is searching against it, and combine that with other data that already exists in Splunk, that's when you may want to build your own custom command. Like say you want to write some, you want to use NumPy for some odd reason to do some statistical calculations of what's being streamed in as a command, or do some kind of aggregate, and you find that the math currently provided in some of the stats commands aren't available. You can basically like, well, I want to build and use this nice little function that's doing a binomial algorithm of some sort to basically calculate something or do some kind of scoring or grouping. You can basically do that yourself.
Is the existing code for the default commands out there already?
No. The SDK has a bunch of examples on how to create and actually build your own commands, but it's up to you to actually know what you want to build and actually the math behind it, or how you want to combine and represent it.
So, would an example of this be the, I saw a demonstration of the RAUT, or I think that's what it's, no, FAUT, F-A-U-T.
What?
Finally, another URL processor, one of your guys wrote it, and it's an embedded search command.
I'm not from Splunk, so I didn't write it.
Oh, yeah.
I don't want to interfere with
No worries.
the conversation, but I am the developer of Spring.
Okay, I'll go ahead and, I think this is probably the most interesting part of using Splunk. I don't know if you've ever developed in Splunk or actually tried to actually do something that wasn't in Splunk. A lot of times you find that like, oh, I know how to use this one library, I know how to use suds, I know how to use response, I know how to use something else. But then you go in to try to like import it, and all of a sudden like, you kind of get this little fail because of the fact that it's not available in Splunk. You can't install additional libraries into Splunk directly. It's basically its own minimalistic Python installation. So you end up finding yourself having to write the long form of all these, basically what it's already provided you in all these Python packages, and basically having to develop what's already been developed, reinventing the wheel. And when I first started developing in Splunk, that was probably my biggest gripe. And like, this is already done for me. All the hard work's already done for me. Why do I have to reinvent the wheel? And so I actually stumbled across someone else's piece of code, which basically showed how to actually put items, libraries, whatever you want, into the run path of Python that's actually running inside of Splunk. So, and I'm going to go ahead and show you that and how to do that. So when you want to add things to Splunk, the easiest way is to actually build an egg file. Basically install pip on your local machine, download the actual source code of that package, unpack that source code, find the actual setup.py, and run this Python setup build dist underscore egg. And you end up with a directory structure that looks similar to what I have on the right, and your egg file will actually just show up in the actual dist directory. I do have some. Oh, go ahead.
You gonna be sharing this presentation?
What?
You gonna be sharing this presentation?
Yeah.
Cool. Thanks.
Sorry, I lost my train of thought now. So there are some caveats with doing this. So this only works well with non-archetype, basically Python modules. So if there is an archetype, like this is specifically built for Windows, there's an archetype for, this is when you build it that it is Linux or it's Mac, this doesn't work well. It gets difficult to manage, especially if, so like things like SUD, REST, request module, those things are no archetype and they have no dependencies, so you can actually import it very easily. But for those items, we're like, well, I really want to use NumPy or I want to use the NLTK Natural Language Processing Toolkit. You have to go to the actual an operating system that what you're running Splunk on, make sure that you have the correct version that matches the correct version of Python that Splunk is running, and then go ahead and build every egg, every dependency, one by one for all the operating systems that you want to run, which is a pain in the ass. Sorry. And it becomes a little unmanageable. And so I don't recommend building anything that's going to be complex that needs to be running on a number of different operating systems. But if you're running this inside of just Linux or one type of operating system, it's pretty straightforward. The actual building the egg, depending on what you need and what's required, like you may require some Fortran, you may require some C libraries, like in Windows. I wouldn't ever try this in because some of the libraries actually require you to install Intel's development toolkit for math libraries that aren't available, and that piece of software costs you about $4,000. So you can get around that by just downloading the trial version of it and then going and compiling what you need and then uninstalling it, or maybe doing it on a VM. And so you're getting around the licensing that way, but I wouldn't actually recommend doing that.
I shudder to know how you found that out.
I'm going to say about 24 hours of just banging my head against why isn't this working. And I actually had to use that technique to actually, for a Hack Week project where I ended up compiling NLTK, SciPy, NumPy, Pandas, and a bunch of other libraries to get the natural language toolkit to actually work inside of Python. It was slow, it was grotesque, I wouldn't recommend it, but it was kind of fun. I learned a lot about how to do this. Yeah, at the time I was probably wanting to pull out my hair, but yeah. So right here, there's a little segment of code. It's a little modified version of the original one I found. But this basically, if you look basically under platforms, the platform variable, this is this little bit of code that will basically load the egg files into the runtime path, and basically will only load the particular eggs for that operating system plus the no archetype eggs. So basically, you can have a bunch of like, you have the Windows, you can have the Linux archetypes all in the same directory, and it basically will find it within the actual path name and actually load those into the run path of Python. And then after that point, you can start loading your actual modules like import suds, import big suds, and so you can basically get around the fact that you can't install something on any given Python if you wanted to.
Pardon my ignorance, but it would appear that the import commands, or the order of import commands matters.
Yeah, so at the top part, you can basically import or do a from in any order, but the items that you have as eggs or the modules that you have to actually load those after you do and loading them into the actual path. And so now to the meat and potatoes, the demo. So give me a few moments while I figure out how to work a browser. So this is a simple Splunk command that actually uses two things. It's a custom log parser that basically, if you know Splunk does one big huge event, and maybe you basically want to strip out and do like a really complex sed command, but it's really not easy to do inside the Splunk sed command itself. So I built one that basically will truncate any given event, no matter how large it is, after 3 lines, and then try to anonymize it and remove all the uniqueness from it to make it easy to categorize and build kind of put them all these groupings, so you can remove like the server name, the ID number, like or something that's unique, or a serial number that's inside the data that makes it appear unique. So it's a command that I built called log check, which is basically is a log strip, and it generates a field called log strip. And then an additional thing that it uses actually uses something called zpunct. I know, I'm describing it before I put it on the board. And zpunct, just if you're familiar with Splunk, it actually does finds all the unique punctuations or punctuation within any given raw data. But what if you want to do a punctuation, find the punctuation for a unique field inside the data, and you don't want the entire raw punct? So I built a command that just, you can pass any given field and it'll do find the punctuation for it, which mimics the punct field based on what is provided inside on the Splunk.com website. So I kind of like took what their requirements and how they said they're doing it and kind of built my own. And then on top of it, I also built another command. So you see 3 commands in this thing. Another one's called Wilson score. If you're familiar with Wilson score, it's basically a binomial algorithm that does scoring and weighting of an event based on some unique numbers that you pass it. Counts, occurrences, how many times it was clicked on, how recent it was, and you can build like, hey, this thing should be at the first item that appears in the list. So it does a scoring, and the Wilson score is actually used by Reddit to actually bring like the most relevant comments and articles to the top. So I built my own custom version of that, trying to do filter out the noise errors based on how they occur with other data. So I'm going to run the command, and hopefully I don't get an error. And let me see. Oops. You can see I'm building a score here based on the occurrence of the error, if it happened near any other errors that are public facing, and kind of let me make this a little more visible. And this is a project that me and Jerome have been working on and off, to try to like weed out all the noise, all the miscategorized errors that people necessarily don't want to look at. And you can see, the command doesn't necessarily order things in the right way, but you can see things with a higher score tend to be something you maybe want to look at, that may be something critical because they happen to occur when someone else is actually, a user is experiencing an error rather than when an error is just occurring within the system randomly. It kind of works, but not really. We're still trying to work on how to get this to work right, and Jerome will actually give a full demo on that. Another interesting command, which I will show some snippets of, is basically the F5 query command that I built.
Scroll up and show us the queries.
No. That has information about our internal systems I don't want to share.
Okay.
So I can't share you the actual search query. But actually, let me do this. Let me pull it off here and remove what I don't want to share. You can see part of it, but not the parts that I care about.
Did you run a prompt on the search command?
Sure. So this is basically the search command. So it's like running log check on this field name message, running a lookup zpunct command, outputting the count and the average from another set of data, filling the value where average is greater than 1. That was some stuff I haven't filtered out yet, but just to make it simple and relevant. And then here's the Wilson score. Here's the average, here's the count, and you can do, we're planning to add more values to this that you can actually calculate that better. So you can calculate the weighting better, maybe on performance, maybe on latency, and some other values, because it's a pretty awesome command, in my opinion. Yeah, so it basically does some more complex of a sed command. So basically, it will truncate after 3 lines. It will strip out some other stuff that it's not necessarily easy to do within the actual sed command. And I think I have, so here we go. Right here is the Wilson score math. So this is what it would look in Python. So that's the mathematical algorithm right there. Oh, I'm not even putting that on the screen. Sorry. So this highlighted section right here, where I'm moving my mouse, is actually the math behind that in Python. It's kind of interesting that you can use this. You can do it straight in Python without any additional math library. So it's not that complex. And if I move that over, I can show you what it looks like in its real form. And I didn't pay attention to what image it was. Nope. Well, I'm going to skip this then one more try. Oh, so that's the actual real math behind the Wilson score. So it looks complex on paper, but in Python, it's really not that complex. It's actually fairly simple. And the final command, which I thought you guys might like to see, is a custom Python command that will actually query an F5 device and pull basically all the stats about the pools, the members, the VIP, whatever you want, and basically display that. And I will show you what the final product looks like if I can get my machine working and know what I'm doing. Oops, I don't have Splunk started. I'm unprepared. 1 second. Okay. 1 second. Don't share that. What won't? No. If this command runs as well as I think it should, give it a few moments. So here you go. It's a dynamically generated dashboard that does basically, if 50% or more of the hosts are out of the pool or not available, it's going to mark it as red. The gold is basically 30% or more of the hosts are out of the pool, unavailable. You may want to look at this. And so you can see this is generating every single pool, and it's dynamically generated. So if you click on this pool right here, it's going to run another search, and it's going to populate what the current connections are, what its current status is for each one of those nodes. And if I completely wired this up, you'd be able to click this pool member name, and it actually run additional searches to pull back the other relevant data about that exists inside of Splunk, not from the F5 API. And it's actually relatively simple to do. If I can bring up my source code, I will show you what the search looks like. Where's PyCharm? So, by the way, this is not being done with the simple XML framework. It's actually straight JavaScript and jQuery. So that's not it. File, open. Oops. And I think I can enlarge this, can I? How do I enlarge text with this thing? And I'm sorry you can't see this very well, but this is actually the custom command right here. It's called F5 query, the pool name that's being passed from the click event, and it says get stats from this device.
Do you have accessibility control scroll turned on? Zoom screen? Just help control and scroll?
I probably don't. I'm sorry. Oh, there we go. Nope. So sorry, guys, I'm failing. But you kind of get the gist of it. You can run any custom command, and this is basically hitting their SOAP API using big suds and allowing the user to pass any number of pools. All the pools get all the VIPs. So the command also does VIPs. it can say like, I want to pull all the VIPs with all their given stats. I want to see if it's available or unavailable. Or you can say, just give me all the VIPs. Don't give me any of the stats. I just want to know what the availability status is. Or you can just say, I just want the pull information. Leave it at that. You can basically specify what you want to by saying like, I want all pulls. I want to get stats equals true. Or I want to get it from a specific device. I can get it from a specific device. I will say that this command is slightly slow if you say that I want everything, because depending on how many objects or how many individual pools that you have in your F5, it could take a while for the F5 to actually respond. I'm actually reworking this to be multi-threaded, so it will launch all of them, all the things that you can launch simultaneously, and that way it will be that much quicker, because basically all these requests are being processed serially. And it's just me being lazy. I think that's the end of my demo, but pretty much you can, if you click this again, of course it rolls back out, click in, click out, and one of the biggest problems I had in that, you see that, that's a bug right there. It's not supposed to finish the search if I move focus, but that's just me not doing it right. So you can see it's broken now. Nope. But do you have any questions? Anything I can answer? The actual visualization piece? The custom command probably took me about a day and a half to whip out, and about another day to add some other features that people asked about and wanted, and to make sure that when people pass things that weren't expected, it didn't just fail and bomb out. Because people just put in whatever they want. And of course you had to, as a developer, have to account for that. The visualization piece, I'm not very good at JavaScript. I'm not very good at jQuery. I've avoided any UI language like jQuery interactive because it's a pain. It's the fact that users want, like, I want this element over here. I want it to be stylized this way, but I want only on this click of it, or when someone on a certain device does this. And for my career, I've just avoided it all. Unfortunately, Splunk is a lot of JavaScript under the hood. And I figured if I wanted to actually do something cool and nice and make things that are useful to people and give dynamic drill downs without people having to learn the search language and actually give views, I'm going to have to invest some time in actually learning jQuery, JavaScript, and some of the other JavaScript libraries out there. But I will say that since you can do all that stuff, you don't have to rely on what's already that Splunk has already said is provided inside there as JavaScript libraries. You want to use Angular? Fine, go ahead. Import the library and do Angular. It's not that big of a deal. So if you see something that you want to do that's not provided in JavaScript and it's JavaScript, add the JavaScript library and start playing around and doing whatever you like. It's like I say, it's a development platform framework that if it's not there and you can think about it and you know a little bit of programming, you can build it. You're not limited to what is provided. It's an extensible tool if you want to put the effort into it.
You could even leverage, if you're comfortable with Python, you could use Matplotlib.
Yeah.
There's an abundance of visualizations that are available out of the box using Matplotlib, which is already here.
Yeah.
That part of the work here, so use Matplotlib.
He's saying that you can use other Python libraries such as math.lib to do your charting instead of using the JavaScript stuff. And at the point, you're no longer relying on the client to render it, and you're basically putting the load on the server. Personally, I'd like to keep the load on the client side rather than the actual server side. You have like maybe 200, 300 dashboards to be, because like you can have 300, 500 users into Splunk doing searches, loading dashboards, which I've had environments that are that large, if not larger, of simultaneous users running stuff. And putting that much load on, say, a few servers is going to make it worse for everybody. So I'd say put things on the client side where you can, put things on the server side where necessary. But hey, you can do whatever you want. That's it for me, and Jerome will be using my laptop to actually give a full demo of what we were trying to do with trying to do error ranking and log analysis as an experiment. Necessarily not the best, and that isn't necessarily true to what it should do, but I think it gives a good idea of what you can do.
All right, thanks.
I'm Jerome. Nice to meet you guys. I doubt I can use a Mac with single-handed, so I'm going to try to drop the mic for a few minutes, and you tell me if you can't hear me, all right? Well, that could work too. All right, so how does that work? All right, this is here.
You want to pull browser?
Browser, yeah, please.
Go to the very bottom of the screen. And just leave
Okay.
your mouse there for a moment.
Over here.
Click.
All right. Where's the click?
I feel the same pain every day.
Thank you. I'm not the only one. All right, that will do. Actually, that won't. That will. All right, so I'm going to try first to explain one of the challenges we were trying to solve. We installed Splunk here about a year ago, and well, the first thing we've noticed is that we did one search over 24 hours, and it came up with about, I don't know, 20 million results or something. And we thought it would be cool if we could like illustrate the most important errors out of this mass of 20 million events or something, as opposed to looking at all of them and all that. And Splunk is great at aggregating all the stuff, but it's not the best at telling you what is more relevant, perhaps. It doesn't have this logic built in, unless you know exactly what you're looking for. So what we've tried to do is to correlate different events. Actually, I'm going to give you a demo first, then you'll probably understand what the heck I'm talking about. All right. Oh, you want to see that one? Megan wants to see it. Okay. So what we're looking at here is that we're correlating more than one source of data. And what we're looking into is, for instance, number of Apache errors, Apache 500, and latency from the customer, right? And more metrics like, well, at some point we're going to plug into that Google Analytics and JavaScript rendering errors and all those things, right? And for more crazy, because we have more instrumentation there. And then we have the error flow. I'm just going to call it a flow from our different server pools. And 4 hours takes a long time. Maybe just a few minutes. So that's probably good enough. So we have this aggregate every day of 20 plus million errors from all our servers. And what I call an error is an application misbehavior, for instance. You can imagine some sort of SQL connection dropped or whatever you can think of. And now by correlating those issues with whatever is happening, the metrics we get from the customer, number of Apache 500, latency and all that, we can, over time, by doing massive pivot operation, look into what's more important. Okay, what error happened? And when I say error, I mean we really look at the punctuation, right? Because we have to strip a few numbers from there and all that. Because every event is really unique. But once you remove everything but the punctuation, you can somewhat aggregate all that. So I'm using Bernie's commands, and it works great. I can't write all that stuff. It's fantastic. So, all right, so we have this flow of events coming at any time, and we correlate this with the number of, I'm going to say, metrics we get from the customer. And should we get, say, for instance, a number of elevated Apache 500 errors at one time, then we know that one of the errors, one of the metrics we get from whichever server has caused some of this pain, right? And over time, we can establish, again, by those massive pivot operation, what are the errors that are the most significant? What is the severity of each error? And now we can look into that, and we can rank them, again, using some of the commands we built. And if we, also I use a bubble chart because I really like it a lot. It's a way to do things in 3D to some extent, right? You have X, Y, and Z, so that's kind of cool. So as you go over those bubbles, it will tell you, okay, well, this one is scored pretty high, and I wish I could zoom out so you can't read it, but okay, we know this error, no, it's cool. This error, I meant out. It's cool. So this error happened 187,000 times, And more recently, in the past 4 hours, it happened only 20 times. Yeah, I should have renamed this, but it's all right. The severity of it, so I can rank them using the Wilson scoring and a few other things he has built. And I can say, okay, well, this exception over here, and if I can click over on it, but anyway, you get the idea, right? Login not found, okay, whatever. We know that this one has a severity of 746. And the truth is there's not too many very severe issues happening right now because, well, we have some good people here and they're still operating the site pretty good. But sometimes something goes terribly wrong, like one of the database server goes down or whatever, and we can see the stuff shifting, right, from the left to the right, because the severity would increase, right? And now we can overlay some of those, and we can say, okay, well, there's something happening here which probably should not, and the severity is much higher, and over the past 4 hours, it has affected 133 customers. So it's not a whole lot, because again, the site is functioning very well right now, but sometimes we get some stuff that's really like, well, it's not looking so good. So, and again over here, the severity is low. Even if they have a higher impact on the number of customers, well, it's not so much of a critical issue. I mean, even if the count is high, 104 customers got this error over here, some mortgage error or something. And well, truthfully, it's not very severe because it did not introduce a higher latency or higher number of Apache 500 errors. So we built this some sort of neural network, right, that learns the behavior of our logs, and it can illustrate within like just a few seconds, you've seen that, what is the most important, what people should be working on, right, or trying to fix, right? And so we have some sort of metric, which is the severity over here, and it's calculated over a few things like Wilson scoring and a few other things as well. And the count of errors, how many times it happened over the past, well, here 4 hours, right? And how many times it happened total, right? And that's that. That's all I got for you today.
Does your scoring depend on how many events actually, or how many errors actually took place?
Yes, okay, yes. All right, so the question is, does the scoring matters? I mean, does the number of events matters in the scoring metric? Yes. So the more events happen, the least it's going to be scored, right? So let's pick this one, for instance, right? This one happened 187,000 times. I can't read it. JSON something, la, 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 la. And because this error happened whenever the site was not exhibiting so many errors, so many Apache 500, and the latency was not high, then this self-learning machine has learned that this error cannot be at the top of the list. But if this error happens to be at the time whenever a lot of Apache errors, on average, a lot of Apache errors, or the latency was high, or Google Analytics metrics were just showing a lot of errors or something, then it knows it has to bump it up a little bit. And so we know we have to work on it. And we do correlation based on different things, right, on more than one metric. And we can rank using that the severity of it, right? You get the idea, right? And it's tricky. So truthfully, it looks like it loaded in like 1 minute maybe, but behind it, because we have this flow of about 20 million errors every day, and we have so many metrics coming to the site, right? I mean, latency and all that, it implies that in the backend we use a very fast database, and which does about 500 million pivots a day, 500 million pivot operation every day, right? So it's all in memory and all that, right? So there's a little bit of logic behind that. It's not entirely all in Splunk, but I thought it was cool. By ranking errors by severity as opposed to number, right? And you've seen that quite a lot, right? I remember this company 10 years ago, and things were quite simple back then, right? The company was just starting, and we didn't have too many servers, and the software was just a few lines of code, really. and so not so many errors came out of it, right? And it was still manageable. And over time, we have learned to take those number of errors and use it as a KPI. Okay, the more errors it is, the worse it can possibly be. But truthfully, as software evolves, it hardly gets better. It gets more complex, for sure. It's like the entropy always increase and never decrease, right? So. And so it gets harder and harder to manage. And you want to build some software to rank things by severity, right? To illustrate out of this flow of 20 million errors or something, what are the most critical ones? And that's the challenge we've been trying to solve. So that's that. Oh yeah, you want animated? So That's yes, we've talked about that, and so yeah, your concern is absolutely sound, and you want to see, okay, what was the picture like? Okay, how was the chart like before we ship this release and after we ship this? How was the stuff shifted on one side or another, right? Did it get better or not, right? And yes, so we do log everything, like version of whichever software we run on whichever box and all those events. And we can look at it like 1 hour ago versus now. I didn't hard code it there, but imagine you could have like some sort of time scale and do some sort of animated stuff, right? It would be like disco.
A display that would let the bubbles move around.
That'd be nice, yeah.
Down one of your F5.
You're hired.
No, I'm just teasing.
During one of the future Splunk user group sessions, we can show how to do it.
Yeah, that would be fantastic. That would be cool. Yeah, so that's that. I think it's cool. Well, thank you. That's all I got today. Bunny, you got something else?
No, I'd like to thank you for coming, but I would also like to say that, like he mentioned, that this is not just running on Splunk. We're using Splunk to do like the quick aggregation, doing all the quick analysis, and shoving that off to an in-memory database, which is a lot faster than Splunk for a specific need, where we can't just query all of the events for all time and basically try to build a number, especially when you're generating close to a terabyte of data a day, and you're like, I want to go and do this analysis all the time and kind of always keep it up to date constantly. It is a high cost, and it's very difficult to do, especially if you don't want to spend hundreds of $1,000s on a big server farm that can do real time. Because if you work with MapReduce, you understand that the faster you want your problem solved, the more servers you need. And that is very costly. So how much is that answer worth to you in terms of time and money? So Splunk works in a similar principle. That's why we decided to offload some of that into an in-memory database that could actually do our aggregation, do some of the analysis and metrics for us outside of Splunk that could hold those long-term numbers. And because Splunk is not a stateful database, you can mimic it, but it still is not a stateful data store. Well, I'd like to thank you for coming.
Can I make an announcement quickly? Sorry, I didn't plan on it. Let me introduce myself. I'm Gregory Melnick. I'm from Splunk Seattle. I'm a product manager in charge of a developer platform, and building all kinds of tools to support your application development on Splunk. So one thing, I hope everybody knows that there is a type of a free developer license that you guys can get, and it's much bigger than the typical 500 meg. You can get 10 gig fully loaded license for 6 months. So if you don't know how to get that, talk to me after this. Or actually go dev.splunk.com and look for the developer license. So that's one thing. People asked for the swag, and I didn't bring any of that. So here's your 10 gig license there. And the other thing is that we actually are about to ship what we call the reference architecture and reference application with the associated applied engineering guidance, where we're showing a end-to-end development of a real kind of comprehensive real-world app, as opposed to small little samples and tutorials that we have online. And if any of you are interested in getting a preview of that, and it's even more importantly, if you're interested in providing feedback on that quickly, within a week or so I can act on it, I'd be happy to add you to the GitHub repo and send you all of the drafts of the developer guide. So please talk to me as well. Thank you.
This is going to be actually posted, so you can actually say maybe your email address to contact.
Oh, right. Okay, good. So gmelnick, Gmelnik, @splunk.com. Very good. Oh my gosh, there's a video. That's even better. Sure.
Just for Zillowites, or what do we call ourselves? Zillans? Zillites? Well, if you guys are interested, and you want to do Splunk development in-house, I'm actually going to start building Vagrant machines, which will mimic our production environment with all the same things. So you don't have to go ahead and reinvent the wheel, and you'll be developing in a similar environments that we have in production, with all the same data sources, all the same layouts, and what's running in production. So as a Zillow employee, I'm working on that for you guys to actually, if you guys want to actually develop inside of Splunk.
Will you be posting that F5 query to a public place?
Nope.
As a former board.
Unfortunately, Zillow doesn't currently have an easy way of exposing things that we build internally, whereas Nordstrom previously had a pretty open agreement with sharing tools. No problem.